A statistics major did not study for his final exam. It was a true-false test, so he decided to flip a coin for the answers. The statistics professor watched the student the entire 2 hours as he was flipping the coin, writing the answer, flipping the coin, writing the answer. At the end of 2 hours, everyone else had left the final except for the one student. The professor walks up to his desk and interrupts the student, saying, "Listen, I can tell that you did not study for this test. You didn't even open the exam. If you're just flipping a coin for your answer, what is taking you so long?" The student replied bitterly as he was still flipping the coin, "Shh, I am checking my answers." And this student is trying to deal with randomness and guess outcomes. So let's go ahead and start this lesson with looking at a challenge, all right? You're working at the Let's Make a Deal show, and they've got a new game called Race to the Finish, and they want an estimate of how often someone will lose. If the loss rate is too high, the game will be too frustrating for players, for fans of the show, and it'll be a dud. If the loss rate is too low, that's going to be more expensive for them. They'll have to budget more for prizes or maybe not even have the game. So this is how you play the game. Basically, you draw cards till you win or lose. Once you get 5 hearts, you win a car. 4 spades, you win a trip. 3 diamonds, you win a computer. 3 clubs, you lose. Now, this game is actually on Let's Make a Deal, and you can actually keep playing even after you win a prize. But right now, all they're worried about is that first point where people are going to be playing till they at least win 1 prize or they lose. So up until that point. So what are some of the challenges to this question? First of all, there are no formulas. All right. It's not like you can go say, "Oh, I know that the third player is going to win the game and the fourth player is going to lose." It's not predictable. The game depends on randomness, which means you don't know which outcome will happen, even if you know all of the possible outcomes. You don't know which cards are going to be drawn, which card will be drawn, but you do know which cards could be drawn. And you can only provide an estimate of the probability, which is actually kind of nice because that kind of gives you an out. In statistics, we rarely have a hard and fast answer for anything. We primarily work from estimates because there's randomness in the world and there will be randomness in the outcomes. So we can't say, "Oh, it will be exactly this." So how do we get an estimate? Well, you could base it on past experience. We could go look at all the games that have been played on Let's Make a Deal and measure what happened, right? But if there is no past experience, so like they're trying the game out before they ever play it, you could do an experiment. Now, we won't be calling these experiments. We have a different word for it. It's called a simulation. So it's not confused with other types of experiments that we'll be dealing with. And if we're going to do that, we're going to need a way to get random outcomes. Okay. So one way we could simulate it is we could actually draw cards. So one way to get the random outcomes is we could be drawing cards. You could be flipping coins. You can roll dice. And there are actually things called random number tables. I gave you one in class for you to hang on to, and I have laminated copies in class for you to refer to. There are actually entire books of random number tables where they go and randomly generate numbers. So they use some device, it could be dice, to create these tables of random numbers. They can even link it to decay of a radioactive element, since that's not predictable either. They've even used lava lamps to generate random digits. Now, in reality, we don't really like flipping coins or drawing cards. We would much rather do something like use a computer to generate random numbers. And computers and calculators can be used to generate random numbers. They're actually pseudo-random. What does pseudo-random mean? It means the computers follow a program. So it starts with some basic number. And from that number, it says, okay, let me generate another number. You can seed these calculators and computers with different numbers so that they behave differently. They're not exactly random, but they're close enough in behavior that we can use them for our simulations. So how do we generate a pseudo-random number with a calculator? Well, first of all, press Math under the alpha key. It's right there. And then you're going to scroll over to PRB for probability. Hold on, let me pull this back. So you hit Math, scroll over to PRB for probability. So there's, see it right there. For integers, press 5 or scroll to randint. So that's the one we got there. Enter the minimum integer, and we suggest 0, which is more like the tables you have. Enter a comma and then a number which is above 7 in this case. So that's your max. The comma is above 7. I'm sorry. You don't need to enter a number above 7. There's the comma right there. And then you enter the maximum integer that you want. So if you want a number from 0 to 9, that's the second. So you can, it's basically randint 0, 9. Close your parentheses. Technically, you could skip and just press enter. And you have it. So I'll play that for you again. Press Math over here. Scroll to PRB. There's 5, randint, your lowest integer, and your highest integer. And there you go. You can keep pressing enter, and it's going to give you a list of integers. You could also do a comma here and say how many integers you want. You notice that there is repetition going on right here.